be studying the surface area and volume of rectangular prisms. As always, take notes and pause as needed. So our first discussion is talking about the surface area of rectangular prisms. If we had a cube, we're trying to find the area of each face of the cube. Remember, the face of our cube, this would be the face. Get a different color. So this is the face of our cube right here. This is the edge. So there's just the side lines are our edges. And then the corners, that you call a corner, that hold all the pieces together, those are our vertices. That's plural. It's vertex for one. So with our cube, we have all of these faces that we have to find the area for. And once we find the area for each face, we can simply add up all of the dimensions and have our value. To find the area, you could also, to make it quicker, do 2 times the top, 2 times the front, and 2 times the side, and add those pieces rather than adding 6 individual ones. So for our first example, we have a 4 by 3 by 5 figure, and we're trying to find the surface area. So to find the surface area of our top, it's 2 times, and our top is this area right here. So this dimension is 4 by 3, and that equals 12. Our next dimension is the front, which is right here, and that dimension is 4 by 5, because it's 4 wide, 5 tall. And our third one is 2 times the side, and that's 3 wide by 5 tall. Sorry, that's 15, not 30. And when we multiply that all out, we have 24 plus 40 plus 30, having a total surface area value. 24 and 40 is 64, plus 30 more is 94 square centimeters, or 94 centimeters squared. So that's the surface area. If we were to paint the figure, that's how much paint we will be needing to cover. So again, that's covering the figure. For our second example, we don't have the individual cubes, but we have the dimensions to help us. So our surface area is 2 times the top. So again, our top dimensions are 5 by 4. So again, that one's going to be 20. Our next dimension is the front, which is right here. So 5 by 7. Whoops. And then our third part is our side, which is 4 wide and 7 tall. So 4 by 7, which is 28. So 2 times 28. And again, I'm saying 2 times everything because we have a side and side, a top and a bottom, and a front and a back. That's why we're multiplying everything by 2. When we do that all together, we have 40 plus 70 plus 60, so 56. When we add those values, we have 70, let's go over here, yep, 166 square centimeters. So that's how to find the surface area of a rectangular prism. Our next concept is getting into the volume of rectangular prisms. And we're going to use the same 2 examples as we did with the surface area. So volume is the amount of space inside the 3-dimensional figures. Think of it as the gift inside the wrapping paper. It is measured in cubic units. So when we find the length of something, that is just a one-dimensional piece of information. When we find, length. When we find the area, now we're getting into two-dimensional because it is we have two pieces that we're looking at. When we get into the volume, now we're getting three-dimensional. So volume is dealing with a length, a width, and a height all together. So a cubic centimeter is a cube that is 1 centimeter wide, 1 centimeter long, and 1 centimeter high. So basically we have 1 centimeter here, 1 centimeter here, and 1 centimeter here. That's what it looks like to have 1 cubic centimeter. Another way to think of volume is to find the number of unit cubes necessary for building the figure. So our example here says 4 centimeters by 3 by 5. Again, same values as the last one. The formula for this, for volume, is the area of the base times the height of the figure. So if we look at this figure, the area we see is 1 squared, 2 squares, 4 cubes, 5 cubes, 6 cubes, 7 cubes, 8, 9, 10, 11, 12. There are 12 cubes on the base of this figure. So 12 centimeter square is on the top of that unit. And there's 1 level of it, 2 levels, 3 levels, 4 levels, 5 levels. So that's what we multiply by the height, because there are 5 groups of 12 centimeters. And we multiply that all together, we get a volume of 60 centimeters cubed. Because again, we have 3 dimensions. It is a cubic unit. So there are 60 squares in the volume of this figure. So again, looking at each cubic layer. Our next example doesn't have the physical cubes, but as our 7 by 5 by 4. If I were to draw the cubes in for a visualization, we can see that it's 5 long by 4 deep. So if we were looking at the top of this, it would look like this: 5 cubes wide, 4 cubes deep. And again, our formula for volume is area of the base times the height of the figure. So the area of our base for this figure is 20 square units. 20 square centimeters times the height. The height of our unit is 7 centimeters. So that means that there are 7 layers. So that's the first layer right there. So that's layer 1, layer 2, layer 3, layer 4, layer 5. So 1, 2, 3, 4, 5, 6. There's 7 layers of cubes stacked that are 20 in a pack. So 20, 20, 20, all the way up to 7 times. Which means the volume is 140 cubic centimeters. So you read that, 140 cubic centimeters is how you read that. Again, it's a cube because you have to visualize that there are 120 of our little pieces mashed together for this unit. And that's volume and surface area of these two figures.